Okay, yeah, so what I'm planning on doing, so the midterm is take home, so that's going to be, you can't talk to anybody. I'll go over this again on Friday. But I will make myself available on Piazza. And you can, if something is unclear on the exam, you can post a question for clarification on Piazza. You can't ask me how am I supposed to do this, but you can ask for clarification. I try to write everything as clear as possible, but of course, there can always be misunderstandings. So I'll be able to answer questions. But yeah, you're not allowed to talk to each other or, ask the TA for help or ask. You can't go on Stack Exchange and post questions there. So can't have someone else do your test for you is basically what I'm saying. Okay. Let's see. We're going to continue on in our blackjack simulation. Okay, so where we left off, we set up all of these things, and we had a manual game. We set up kind of all of these actions for splitting cards, for hitting a hand, standing, for double downing and splitting a pair. We created a function to draw cards for the dealer. We created a function to prompt the user for an action. And I think there was some questions as, so it used to say strategy, and I kind of wrote it here as action function. So we created kind of a way to automate the gameplay here using this function play underscore hand. And what this does is it takes the shoe, which is how it's going to generate new cards, and then on Monday I had written it as strategy, but perhaps another way is that may be easier to understand is called the action function, okay? And we can implement a simple strategy that says, you're going to stand if the dealer shows less than a 6, or I guess dealer shows 6 or less, and you're going to hit if the dealer shows 7 or more, okay? Type of thing, as long as you don't bust. So that was the action function. Or, we can use the prompt the user to determine which action, okay? And then, we start off by creating new hands, and we have all of this, okay? I further went ahead, so we have our simple strategy implemented here, and we could test it out. I guess I have it written as strategy again, just because that's what's used in the thing. But when you see strategy here, you can just think of this as the action function. It's a function that basically, based on the cards you have and what the dealer shows, returns an action to take. And whether that's stand or hit, double down, or split, you can write that as a code to automate it, or we have the code that prompts the user. And so you can have an interactive game by prompting the user, or we can implement a strategy for it. So I went ahead and took the kind of more complete version, because when we did it on Monday, we just had stand, hit, and double down. And we didn't have anything for splitting a pair. So this one basically just expands that and creates the option for what to do when you split. There's also an extra argument here that says verbose. Okay, so and the difference here is that, so last time, is it okay that I'm just talking about Monday as if you guys remember stuff, and I'm hoping you guys do. We had I just commented these things out because this would print out exactly what the dealer had and what you had, and did all of this stuff. But we're going to basically put this stuff as to whether we should print this out rather than manually commenting or uncommenting it. We're putting it inside a section that says if verbose, meaning if you want the function to print out everything that's going on, you can do verbose equal to true, and then it will print out what the dealer has and what you have and all of that, so you can kind of make sure it's behaving the way you want it to behave. Or you can just leave it false, which is the default method, which we would prefer when we're just going to replicate, 1,000 games so that it plays quickly. Okay. So we created an extra argument called verbose, and again, I'll walk you through this play hand code. It starts off by taking the first card that the dealer has and making that the face card, or the face up card. This is the card that's visible to you, and that will play into the action you take, or the strategy, as it says. Okay, and so the action that we take is based on our strategy, whether that's prompting the user or using our simple strategy, or later on we're going to use a lookup table to kind of use the optimal strategy, which has already been solved mathematically by some guys, I think, in the 60s. Okay, and so we take the cards that we have in our hand and the dealer's face-up card, and we decide what to do. So based on this action, which is a function, okay, it's called strategy, but we're feeding this a function, okay? So the function takes these two arguments and returns what action to take, okay? And so it says if you hit, then hit the hand and ask for an action again. If it says double down, then double down the hand and stand, okay? And if it says split, so this is how we're implementing split, we're going to run our function split pair. And when we run split pair, if you don't remember, okay, split pair takes the hand and returns two new hands, okay? So split pair returns two new hands, it returns a list with two new hands, okay? And so after we split it, okay, we're going to, so when we run split pair on the hand, this is now a list with two hands, right? So hands is the list that split pair returns, okay? So there's two hands inside here, okay? And so hands 1 is the first hand that split pair returns, and hands 2 is the second hand that split pair returns, okay? And so if we go back to the split pair code, split pair will take each of our cards and deal us a new card. So it returns a hand with two cards in it, okay? So we do that, and then, and rather than just stopping, now we are recursively calling play hand on each of the two hands that are drawn. Okay, so this is, so read through this, make sure you understand it. So when we call split pair, we get back a list of two hands, and we take each of those hands and we recursively call play hand on each of those hands. Okay, and so here it says use the same shoe that we have, use the same strategy or same action function. Okay, so if it's prompt the user, continue prompting the user. If it's whatever it is, using the simple strategy, continue using that. Okay, use the same arguments for verbose, use the same arguments for dealer. So the only thing here is we're basically just calling play hand on ourselves, but we're giving it each of the two hands, okay? And so remember that the result of play hand is just the winnings. And so at the very end of this, after we finish recursively calling play hand, it's going to return 1 and 2, okay? There's we have not enforced any kind of check on split pair to make sure that we're not splitting pairs again and again. So in real life Vegas, you can't keep splitting your pairs, okay? So if you get 2 10s, you can't split them. And then if you get dealt another 10 here, you can't split that again, okay? So in real life Vegas, once you split, you've got to keep playing. And then sometimes, depending on what happens, okay? So here we're saying keep playing, meaning you can hit or stand. But sometimes in Vegas, depending on the rules, after you split, you're basically double downing, okay? You split, you get a new card, and then that's it. You can't continue hitting, okay? So depending on which casino and the rules of the house, these things might change. All right, but here we're just continuing to call play hand here. All right. Is this okay with everybody? Yes.
Did you put this .r on the CC link?
I have not yet put it up. Okay, I will. I think I guess I didn't want to keep uploading it and then taking it down and then uploading it with a updated version, but I suppose I could do that if that will be helpful. Okay, all right, I'll do that. So I'll upload this version up, and then for you know, the midterm, I imagine we'll have some questions related to this where you know, maybe I'll have you modify things to impose, you know, casino rules. Okay, so depending on casino rules, I think that's a fair question. Maybe I'm giving away a little bit already about what kind of action you might be required to do on the midterm. Is, you know, I might say modify this function so that it does this thing, you know. Okay, so anyway, we do that, and then if it's verbose, it'll print out all of the hand information. If it's not verbose, it won't. And then we return the winnings, okay? So let's run this, and we can just kind of see if this will work. So I can implement simple strategy. So if you remember simple strategy, where did it go? Okay, simple strategy just says if you have less than 17 and the dealer is showing a 7 or higher, hit. But if you have less than 7, but for anything else, meaning if you have over 17, you're going to stand, or if the dealer shows less than a 6 or less, you're going to stand. Okay, so if the dealer shows a 3 and you've got whatever, you're just going to stand. Okay, so this is, you know, this is not the best strategy, but it's a pretty safe one. Okay. So we can try playing whoops, simple strategy didn't work. Let's try this. Oh, strategy simple is not the correct word. It's called simple underscore strategy. Okay, so it played. The dealer had 4-5, so you know it doesn't tell you exactly what happened. It said 4-5, which means the dealer had 9, and it was showing 4. It was showing 4, and we had 12 at the time. So according to our simple strategy, the dealer is showing 4. Even though we had 12, we stand. We chose to stand, which was actually good because if we chose to hit, we would have gotten this 10, and we would have bust, right? But the dealer had 9, they hit, they got to 19, and they beat us. And so the end of that thing is that we lost our dollar. Okay, so here we lost again. Here it says dealer had 5-6. We saw the 5, so we stood at 15, and they drew an 8, so we lost. You know, they showed an 8. And you know, we had 6, 8, so we said hit, right? Because it showed an 8. So we said hit. We got to 17 and we chose to stand, which is generally a good idea, but they beat us with a 10. So here we push, okay? I'm trying to see if we get... okay, so here, yeah, we keep losing, right? So they had a 10, 10, but we were at 20. We chose to stand. Okay, so in this case, we can also do a play hand when we're going to prompt the user. So in this case, now it's using prompt user to choose what action to take next, right? So this is now the function. So simple strategy, it only just did stand or hit. Okay, with prompt user, now we can choose hit, stand, or double down. So the dealer has 3. We have a 6, 10. Okay, what do you think we should do? We're going to stand, and we're going to see what happens. They pulled an 8. What do you know? Okay, so we lose. All right. All right, the dealer shows 2. We have a 6. Okay, so let's hit. Okay, we're now at 17. Let's stand. Okay, and the dealer pulled a 6, 5. You know, this actually feels very much like playing in Vegas. Okay. You should try it someday. Okay. All right. So, oh, look at that. So we have blackjack. So and the dealer has blackjack. So we just push. Okay. Man, this is life is hard. Okay. So we're at 16. The dealer shows an ace. So we got a hit, right? Oh, okay. Now we have 17. All right. We'll just stand. Oh, look at that. The dealer busts. So finally, we win $1 back after our thing. I'm trying to see if we can pull a pair. But, so we didn't implement any checks on split pairs, so I can say just split. Now, this is totally illegal in Vegas, and that you are not allowed. But because we didn't implement any checks here, we can just say split it, okay? And so we've split, and so our first card is an 8, so it doesn't tell you what happens, but so we started off with an 8, and then we drew a, so this is our first split hand, and then apparently we drew a 10, so we have an 18. So we're gonna stand for this one, okay? And then the other hand, it revealed to us what the dealer has. Well, this plays into our strategy now. Okay, so this is probably maybe some deficiencies in our. So we now know what the dealer has. But so we have 10, 10, 5. So when we split the 8, 10, we got the 10 and we drew a 5. And so we want to hit. And we got 16. Let's hit again. And we bust. Okay, so what happens here is, so this hand we pushed, so we got 0. This hand we lost. So in total, we have a -1. Let's try this split nonsense again. Okay, splitting this. Okay, so we take our 3. This comes over here. We got a 9. Let's hit. Okay, 16. So we'll stand there. Okay, so we are... All right, so this is not the best in that we already know what the dealer's going to end up with. Okay, so with the 9, we have a 6, so let's hit it and just see what happens. Okay, so in that case, oh no, I accidentally hit stand. So I lost this one because 16 to 17 I lose, 15 to 17 I lose, so now I'm at -2 here. Okay, so our splitting function works, although there is a deficiency in that at the end of showing the results of our first hand, it also tells you what the dealer has, which allows you to cheat for the second hand. But in terms of the actions it takes, it works, okay? All right, so what we're going to do now is we're going to use a lookup table to implement the optimal strategy. Okay, so if you go to blackjack on Wikipedia, there we we go. Okay, we have this, they have solved the optimal table. Now, this is not, we can't use this directly, so on CCLE I've created, I've uploaded the CSV file that you need, okay? So if we open this, so this says exactly what you need to do. So if you have a 20, you know, any of these things, you'll either stand, hit, double down. DH means double down if it's allowed, or hit if you're not allowed to do that. DS is double down or stand, things like that, okay? We didn't implement a surrender function, so on the over here it says surrender, but here we're just gonna stand. Okay. The difference between a hard and a soft is that in a soft soft totals, so this would be ace 8 would be a soft 19, so and ace 7 would be a soft 18. Okay. Over here it would be a hard 18. So hard means if you hit, you can't, there's no cushion here, right? With the ace can be a 1 or an 11, meaning if it were to bust, the ace, you know, cushions yourself and drops down 10 points for you, okay? And then the pairs, this is what to do, okay? So if you have a pair and you've got a pair of 2, you know, things like that. Okay, so we're going to implement this, and I was having trouble downloading the function directly, the table directly in R. So let me just, we're going to, you're going to have to download the strategy lookup table, okay, and read that in. And we're going to store that as lookup table in our blackjack code. Okay, so now this is, here I'll write implement optimal strategy with a lookup table. Now, because it's because this has been solved, this is optimal strategy. But if you know, if you wanted to change this, or perhaps if the rules were different, okay. So this optimal strategy that we have here is based on certain assumptions, okay. And so perhaps if any of these were different, then the optimal strategy might actually be different also, okay? So you could change the lookup table accordingly. All right, so we're going to read this in. We've got our lookup table. We can ask, what does our lookup table look like? And it looks the way we have it, okay? It has the type, your value, and then this is based on what the dealer shows, okay? All right, and so we're going to create a function called strategy optimal. And what strategy optimal does is it basically takes your hand and it looks it up in the table. And there's a lot of code here, but it's not that bad. Okay, so we're basically just taking the player hand and the dealer face up, okay, and then and we provide this optional argument optimal equal to lookup table. Now, so remember this is our action function, or in our play hand it's our strategy. So we're calling this strategy underscore optimal. That goes in here, and so within our play hand function for action we're giving it 2 arguments, the cards in our hand and the face-up card that we see. Okay, and so that's going to be, you know, dealer face-up and our player hand, and then we give it this default argument, so we don't have to worry about it. Okay, so what this basically just says is our our hand is worth, we call the hand value on this, and we say, if we've got 0 or a blackjack, okay, or 21, then we stand. Okay, otherwise, we're going to have to use the kind of lookup table, all right? So we're going to see if we have an ace in our hand, okay? And so if our player hand has an ace in it, okay, then then we have an ace, okay? So this is going to be a true false. Dealer value is what we see the dealer have, okay? And so basically, if we have 2 cards in our hand and both cards are the same, then we have type equal to pair, okay? And if we have two aces in here, okay, so if one of them's an ace and it's a pair, then we're going to call this player value equal to 2, because hand value with 2 aces will evaluate it to equal 12, right? Hand value says ace is equal to 12, but we need to say, when you look it up in the table, look up the value 2, okay? So this is just kind of a special check just to see if we have 2 aces right here, and also to check if we have a pair. And then over here, then we say, do we have an ace? Then it's a soft total. Otherwise, it's a hard total. Okay, so this is just to check what type of hand we have, whether it's a pair, a soft total, or hard total. So I can write this in here. Check which kind of hand we have: soft, hard, or pair. Okay. And then the out is the action that we take. Do we want to hit, stand, or double down? Okay. So we would just look up. Okay. So we can create an argument here, which is basically. So keep in mind what this does, right? So this is a vector of true falses, and this is also a vector of true falses, okay? So if we have type equal to hard, we're going to look at the our lookup table, right? Lookup $type, we're looking at this thing, and it's going to say true for wherever these rows are true, okay? And then we look up the value for this, and it's also going to be true false. So every time, every combination is only going to return one row that hits true here and true here. Okay, so this is vector notation. This will return only one row where both the type is equal to the type and the value is equal to the value. So this is only going to return one row where it's true for both. Everything else will, if one of them's false, the AND is going to return false, right? And then we look up the column with the appropriate dealer value. Okay, so we look at that intersection, and that's going to be what we have. And then now we just have to say, okay, well, what do we do? Dealer hand and dealer split, okay? Or I mean dealer stand, or not, sorry. Double or hit, double or stand. So here, if the length, if we have more than 2 cards in our hand, we can't double down, right? We can only double down if we only have 1 card. So here, if we have more than 2 cards, we have to hit. Otherwise, if we only have 2 cards, we can double down. Okay, so this implements which action to take, and these are special situations where we have either double down or hit, double down or stand. Okay, double down if it's allowed, which is it's only allowed when you only have 2 cards. So here we can implement our optimal strategy as such. Okay, and so now we can play with the optimal strategy. Strategy optimal. And then it says, so under strategy optimal, we happen to win. And here, look at that. Change of our luck, we're winning with the optimal strategy. Okay. Okay, so the dealer beat us there. Okay. But we're winning, whoops. And we're getting, that's crazy hand, right? 2, 2, 2, 7, 7. So, you know, we hit every single time here, but we lost. Okay, so let me see, I want to see if it pulls off a split anywhere in here. Come on, show me a split. No, oh wait, there it goes. So here was a split. Okay, so we got 2 3s and then we split. And then look at that, we won both of our hands. So, so that's exciting. Okay. Okay, so now, so we can do this, and we can do verbose, or leave verbose off, okay, and just see what happens, and we can run a whole bunch of replications of this, and so we can see how, you know, we'll do, we're going to implement the optimal strategy, run it 1,000 times, and just see what happens. Okay, and so let's go optimal results. So we ran it 1,000 times, and then we can compare our optimal results versus strategy simple, right? Or simple strategy, I think is what we called it. So, you know, if you can't remember all the optimal results, you know, like what actions to take, you know, if you were to go to Vegas and just use the simple strategy, which is very easy to remember, okay, we can compare how the optimal results compare to the simple results. So let's see. Okay, so we can ask mean of the optimal results. Okay, oh, look at that. We came out ahead, 19 cents. No, 2 cents on the dollar. And then we can do mean of the simple results. And we're losing about 7 cents on the dollar. And of course, this is different. We could, let me try doing 10,000 replications and just see what happens. And we can do 10,000 replications. So mean on the optimal results, okay, we're losing about 1.50 cents per game. And mean of the simple results, you know, we're losing about 8 cents, 8 points, about 8 to 9 cents per game. Okay, so we can see how the optimal results, you know, optimal strategy compares to the simple strategy here. Just by replicating, you know, we're playing 10,000 blackjack games here, and then, and so we can get an idea. So, you know, even with something complicated like blackjack, people have managed to solve it analytically, okay? But, you know, if we wanted to just try out different strategies, say, hey, what if we did this instead? We can, you know, rather than having to redo all the math calculations, we can just change the action that we take in our lookup table and then run thousands of replications or more, depending on how thorough the results you want, and see what happens, okay? We can, with our optimal results, we can create a histogram of that, okay? And we can see, this is what happens. So, you know what, let me, I forgot the code for creating a density graph. So we can, so this basically, I think all I have to do instead of histogram, I'm going to just do density, which prints out, oh, I have to do plot density. Okay, so this is kind of this is the results of under our optimal strategy, what happens, okay? So we see, we push about this often, we lose our dollar about this often, we gain $1 about this often, we gain $2 around here, we lose $2 around here. How do we get out here? What's going on here? How do we gain more than $2?
Is it doubling twice?
No, I don't think, I guess that's possible. But what happens is we're splitting and then we're hitting a blackjack. Okay, so we're getting like 2 aces and we split and we get blackjack. And over here is just the opposite, right? Oh wait, no. How do we get negative down here? Let me think. Oh, I guess we split and then we double down? That must be what's going down here. And again, not everything is possible, and apparently, we're getting things. Apparently, you can get negative 5.5, which is rather unfortunate. And I'm just trying to think what happens there. So perhaps we're splitting more than once because we haven't implemented any kind of check or regulation on that. But this is kind of neat. You can see how this looks, and we can also plot the density of our simple results. Okay, and so with the simple results, we're either hitting or standing. So we're either going to lose $1, come out even, win $1, or get blackjack. Okay, and so this is all that happens with the simple strategy, and this is so we can see how the optimal versus the simple strategy compare. Okay, and I think this prints them on top of each other. Let me just do simple results and optimal results. So this one just superimposes the two graphs, and we can see. So we see there, there's a lot of overlap between the optimal and the simple, but the optimal gives you kind of the ability to split. So you have this out here, but that also takes its own risk. It thus reduces the probability of these ones because the total area has to be under 1, right? Okay, and then and we can further simulate things like, well, I'm not going to play 10,000 games of blackjack, right? But maybe you'll go to Las Vegas and say I'm going to play 50 games or something like that. Okay, and then so you can see, well, what's going to happen if I play 50 games, and maybe you come out at $50 ahead, which would be incredibly unlikely, but maybe after playing 50 games you come out a few bucks ahead, or after 50 games you come out a few bucks behind, something like that, assuming you're using either the simple or the optimal strategy and just seeing what happens. We can simulate something like that. Okay, so what we're going to do is we're going to create another function called payoff. Okay, and so let's just explore how this function payoff works. Okay, and so basically payoff is we're just replicating this. Okay, but it also calculates a few things: the average, the standard deviation of our gains, and the median of our gains. So we're just going to play our hand using the strategy that we specify in payoff, and we can say, what kind of payoff will we get after 50 playing 50 games here. And so with 50 playing, no, simple underscore strategy. So playing 50 games, it then reports back to our, the average gain after 50 games was this, and the standard deviation of our gain is this, and then our median is -1. But of course, this is a random sample of 50 games, so if I played another 50 games, you know, I get different results. So every time I play 50 games, this time I came ahead, this time I lost more, things like that, okay? So we can see, you know, every time I play 50 games, the results are a little bit different. So what we want to do is we want to replicate this in of itself, okay? So we're going to replicate this this payoff function. Okay, so this is just summarize. So payoff is summarize some stats on a session of blackjack. Okay, and so this says, okay, repeat the payoff function 1,000 times. So this is playing 1,000, having 1,000 different sessions of playing 50 blackjack games. All right, and then we can see what happens here. Okay, and we can, and it takes a while because we're doing 50 games 1,000 times, and then we're going to do the same thing using the optimal strategy. Okay, so this is playing 50 games with the optimal strategy 1,000 times. So this is 1,000 sessions of 50 games. And then now we can kind of compare, whoops. How these compare. So, this is kind of a pain here, but we're gonna just take a look at this average gain value. Okay, so we got 1,000 different average gain values here, and we're going to just create a data frame of this, and we can plot that. Okay, and so this looks a little crazy here, but basically what this shows is that with the optimal strategy, which is in red, okay, it's all funny looking because, you know, we just played only 1,000 sessions of 50, right? You know, if we did, you know, 10,000 or 100,000, it'd be a lot more smooth, but that would take a long time to run on our computer. And so we see, you know, when you just play 50 games, sometimes you come out a tiny bit ahead, sometimes you come out behind, and, you know, you can come out way ahead, not very often, and you can come out way behind, also not very often. Most of the time you're coming somewhere around the middle. But we see under the simple strategy, the most common occurrence is you win a few bucks. I mean, you lose a few bucks, okay? But under the optimal strategy, the most common occurrence is that you actually come out ahead a few pennies, all right? So this is kind of neat, right? This is just implementing a simple win or lose scenario here. Okay, so that covers that for today. So on Friday, we're going to just talk about a persistent shoe using a reference class where we're keeping track of all the cards that have been dealt, and then I'll explain basically just a little bit more about the midterm exam itself.